Welcome to iLectureOnline. Another typical max-min problem is finding the point on a graph that has the closest distance to a given point. So here we have an equation, y equals x squared plus 1, and the associated graph with it. And we're given a point 3, 1, and we're trying to find the point on the graph that is the closest to the given point. How do we do that? Well, the strategy is that we'll come up with some equation for this distance, and then, of course, try to minimize that distance. So the equation, the second question then is, what is being maximized or minimized in this case? And the answer is, we're trying to minimize the distance between a given point on the graph, let's call it xy, and the given point 3, 1. So step 2, we're trying to minimize the distance. Now we need an equation. Of course, we're going to use the distance formula. The distance formula tells us that d is equal to the square root of the sum of the differences between the x values of these 2 points and the y values of these 2 points. That means we get x minus 3 is the difference between the x values squared plus y minus 1, which is the difference in the y value squared. But again, notice that our equation for the distance that we're trying to minimize has 2 unknown variables, x and y, which means we're going to need a constraint to allow us to eliminate one of those variables. Step 4, we need a constraint. And a constraint in this case is that the point must be on the graph, which means the point must follow the equation y equals x squared plus 1, which means that is our constraint. Which means that y can be replaced by x squared plus 1 in our equation right here. Let's go ahead and do that. And now we'll have an equation that only has one variable x in it. So d is equal to the square root of x minus 3 squared plus, instead of y, we write x squared plus 1 minus 1 quantity squared. So now we can go ahead and expand this out. We have d is equal to the square root of x squared minus 6x plus 9, and here the ones cancel out, so we get plus x squared squared, which is x to the 4th power. All right, now we can go ahead and go to the next step where we are going to take the derivative. And I'm running out of room, but let's try it. Well, let's move over here. Gives me a little bit more room. And now we're going to take the derivative. And we write y prime, I guess this would now be step 6 because step 5 is where we use the constraint to eliminate one of our variables. Step 6, we take the derivative d prime is equal to, so we have the contents to the 1/2 power, so it's 1/2 times this quantity to the minus 1/2 power, which puts it in the denominator, the square root of x squared minus 6x, I'm getting ahead of myself, 6x plus 9 plus x to the 4th power, and then times the derivative, what's inside what goes in the numerator, which gives us 2x minus 6 plus 4x cubed. And then we're going to set that equal to 0. So we set d prime equal to 0. Now here we have a fraction. And we set a fraction equal to 0, that means the denominator doesn't really matter, because if the numerator is 0, the denominator is irrelevant. So that means we are okay with just setting the numerator equal to 0. That means that 0 is equal to 1/2 times 2x minus 6 plus 4x cubed. And then multiplying the 1/2 through, we simplify this by saying this is equal to x minus 3 plus 2x cubed. Now we have to go ahead and find the solution to that, find the root of that. And that's a little bit more difficult to do because it's a cubic function. However, we usually can guess by using what we call synthetic division. So let's go ahead and do that. We're going to solve this using synthetic division and guess for some roots. Now I can see here that most likely our function or our point is somewhere in this neighborhood. So I'm going to try some different roots and see what we end up with. So synthetic division tells us that we have a 2 for the x cubed, a 0 for the x squared, a 1 for the x, and a minus 3 for the constant. And let's try some possible roots. I'll try x equals 2, see if that gets me anywhere. So we drop down to 2. 2 times 2 is 4. Added together, I get 4. 2 times 4 is 8. Added together, I get 9. 2 times 9 is 18. Added together, I get a positive 15, which of course is not 0. So the root 2 didn't work for us, so let's try x equals 1 and see if that works. Again, using synthetic division, we have the coefficients for the x cubed term. We have 2, 0 for the x squared term, 1 for the x to the first power, and a constant minus 3. So let's try 1 as a root. So we drop down to 2. 1 times 2 is 2. Add together, I get 2. 1 times 2 is 2. Add together, I get 3. 1 times 3, 3. Add together, I get 0, which means that x equals 1 is one of the roots. Well, if x equals 1, we can then find the value for y because we have to plug it right back in here. So we have y is equal to x squared plus 1, which is 1 squared plus 1, which is 2. So x equals 1, y equals 2 is the point on the graph that is closest to the given point 3 and 1. So the solution, the x, y coordinates that we're looking for, is equal to 1 and 2. And that gives us the correct answer. Now, to check to see what the distance is between that point and this point right here, what we can do is we can plug it back into our distance equation. If x is equal to 1, 1 minus 3 is negative 2, squared is 4. So let's go ahead and do that. So d is equal to the square root of 1 minus 3 squared plus y minus 1, y is 2, that's 2 minus 1 squared, which is equal to the square root of 4 plus 1, which is equal to the square root of 5. Now what you could do is you could take a value on either side of that given point and see if the number gets bigger or smaller. And just take one other point on the graph. Let's say if x is equal to 2, y is equal to 5. So if you try to point xy equal to 2 and 5 and see what happens to the distance. Distance is equal to the square root of, well, x is going to be 2, so 2 minus 3 squared plus, that would be 5 minus 1 squared. And notice, that doesn't need to be up there, equals, and that gives us 1 plus 4 squared, that's 16. That would be the square root of 17, which of course is bigger than the square root of 5. So we can take a point on the other side, and again you'll notice that the number becomes bigger. And so we probably found the correct value for the point on the graph. Let's do a quick recap. We first graph the graph of the equation that was given to us, x squared plus 1, which is a parabola, and they give us a point 3 and 1, and we're trying to find a point on the graph that's closest to the given point. So we determined that we're trying to minimize the distance between the given point and the curve, or a point on the curve. We use the distance formula because that's what we're trying to minimize. And then we realize that we have distance in terms of two variables. We use a constraint, the equation, to determine y in terms of x. We plug that back in here, substitute that for y. Now we have the distance formula only in terms of x. We now take the derivative. We set it equal to 0. When we take the derivative of something like a square root, we get 1/2 times this quantity to the minus 1/2 power, which puts on the denominator, times the derivative of what's inside, which is what we're really after. Because when we set a derivative equal to 0, the denominator has no function, because if the numerator is 0, the whole fraction is equal to 0. So we're only concerned about the numerator. So we set the numerator equal to 0. Now we solve for x, but we have an equation to the third power, a third order equation, which means it takes a little bit of guesswork to try and find the root. We tried 2, it didn't give us a value 0 there, so that was not it. But when we tried x equals 1 as a root, Then we realize, yes, that is one of the roots, so therefore we can find the corresponding value for y, and then we realize that the point xy equals to 1, 2 is the closest point in the graph to the given point. And that's how it's done.